All right, greetings everyone. My name is DBrown, and today I'll be presenting on decision support and how explainable AI can improve transparency and trust. And so this is research is introducing the effective analytical decision framework, which integrates emotional and logical models to enhance AI decision making, transparency, and trustworthiness. It was developed in collaboration with Dr. Liu and Dr. Rawat as part of Howard University's effort in advancing human-centered AI research. And so a quick agenda for today. First, we'll explore the problem statement and objectives of the research. An introduction, we'll go through motivation and research gap, looking at trust, integration, and emotion. We'll look at some of the foundational theories of explainable AI, decision support systems, Bayesian networks, and human-centered AI. And then we'll look at the proposed framework for AADF, or the Effective Analytic Decision Framework, and some of the examples. And so then we'll go into conclusion to hit on the future work and some acknowledgments. And so for introduction, we're looking at AI systems for decision support are rapidly evolving, and so some of them may lack initially with the ability to integrate emotional intelligence and trust, which is crucial for human-centric applications. This research proposes the Effective Analytic Decision Framework, or AADF, which bridges that emotional and analytical decision with those emotional and analytical decision models. The objective is to create emotionally intelligent AI systems that can handle uncertainty, foster transparency, and ultimately improve the decision-making process. And so that's very critical in domains like national security, health, and healthcare, where trust is and explainability is paramount. So not only being able to explain it, but also being able to trust that that system is making the correct decision or is able to do that process effectively. So some of the motivation and some of the research gaps that we're going to take a look at is that traditional AI systems treat emotion as noise rather than data or a signal in the model. And so this creates a significant gap in in the model's ability to handle that human-centric kind of decision-making process. And so the AADF framework is looking to merge those by introducing emotional models into AI decision making, some of that explainable AI principles, and then adapting some Bayesian networks for uncertainty management, and then merging those with real-time analytics and user-centric decision support models or frameworks. And so that's filling the gap between the static and logical models and the need for an adaptive emotional AI intelligence systems. And so we'll get more into that as we go forward. And so now the foundational theories, we'll go through each theory to kind of see how we're going to use it in AADF. And so first one is explainable AI. And so some of the key principles here is we're looking at the human-centered approach to simplify complex AI decision processes. We're looking at transparency to build some of those trust by ensuring that the users understand the decision-making process. And then we're looking at fairness to address the biases and ensuring equitable and ethical AI behavior. And so these principles are critical for enhancing that trustworthiness of AI systems in sensitive decision-making scenarios. And so moving on to decision support systems for foundational theory is that DSSs are in the AADF model or framework enables that framework to move from static models to adaptive when considering real-time analytics. And so we're focusing on large data sets with complex scenarios, adaptive structuration theory for collaboration, middle-out design for user-centered development, and predictive analytics with AI decision making. And so this is integrating AI with collaborative systems for dynamic decision making and prioritizing a user-centric approach where human input kind of shapes all of those AI outputs. And so that ensures that the system remains flexible and relevant even when it's in an environment that's rapidly changing. So next one is the foundational theory of Bayesian networks. And so Bayesian networks shine really when it's handling uncertainty. And so that's why I selected this one for the AADF model or framework. And so they usually visualize interdependencies among variables and kind of provide that probabilistic understanding of events, and uses very heavily on domain knowledge to integration to ensure that the model remains grounded in kind of that real world expertise. And so improving that explainability and visualizing those dependencies while also having those probabilistic outcomes with domain knowledge is extremely useful. And so the next foundational theory is looking at human-centered AI. And so with human-centered AI, we're looking at the component that ensures the AADF model prioritizes ethical and intuitive design. And so we're looking at a participatory kind of approach where that domain-specific knowledge is helping guide the AI system. And then the transparency and accountability kind of ensures that decisions can be tracked back to that human oversight. And then ethical considerations kind of ensure that the AI actions kind of align with societal norms and values. And so that component kind of underscores or this component kind of underscores the importance of keeping the human, whether it's in the loop, on the loop, or monitoring that whole situation or that whole process. And so the effective analytical decision framework, kind of like an over broadening view of it, is that it at its core has explainable AI encapsulated around a decision support system with Bayesian networks as kind of like the uncertainty portion, and then wrapped around the whole entire process is the human-centered AI approach. And so using emotional models that use, we'll get into this, but directed acyclic graphs to kind of map those stimuli, the primary, secondary, and emotional responses, which influence those subsequent actions. And then also the logical models that kind of have the traditional approach to map like observations, analysis, inferences, and decisions. And so that dual layer approach is kind of what I'm looking at here, to be able to have the decision support system and Bayesian networks, which are very analytical and logical, and then the human-centered AI, which are very focused on the human-centered approach. And so first we'll look at emotional DAGs. And so this is kind of a simplified emotion kind of model or approach. And so step one here is looking at emotional models that kind of process those stimuli and then generate kind of a primary, secondary emotional responses. And so for example, right here we have stimulus, they have a primary emotional response, a secondary emotional response, and then an action. And so how that looks at it is like, well, maybe there's a threat, then there's a fear, anxiety, and then the action would be avoidance. And so these are nodes that are connected by edges that have probability of happening or kind of have those weights on there. And so that kind of helps us kind of like explain how the AI decision making process ensures that the action like deploying diplomatic resources align with the emotional context of that event. And so let's move on to the logical DAGs on step 2. And so this one is looking at how these models process structured observations, such as event data from one of the data sets that I will use, and I'll show you in the next step. And so through that analysis is using an observation, analysis, inference, and a decision. Very traditional, and it's looking at, an event type in this data set is observed, and then the model infers maybe a high severity, and then recommends deploying, the action is maybe deploying resources. And so, going through this combination of emotional and logical DAGs ensures that the decisions are both analytically sound, but then also emotionally aligned. So step 3 for the decision support system, it could be using a simple random forest classifier. So the data set that was used was the armed conflict location and event data set, which was created by University of Sussex. And so I looked at from Ukraine from 2005 to 2024 and just created a very simple classifier using some of those features in the classification report. And so the classification or the report using a random forest classifier, when it had no fatalities, the precision was 95%, recall was 96%, and then when it had fatalities, the precision was 61 and recall was 57, with an accuracy of 92. And so these are just some preliminary results of how a DSS could be used with the AADF framework. And then so step 4 for Bayesian networks. Is calculate kind of like the probabilistic distributions. And so the library uses PG and PY just to help identify joint probability distribution for events like fatalities when the event type was 1. And so, for example, if evidence suggests that a high likelihood of fatalities, the model would adjust its recommendation accordingly and leveraging that phi function to join evidence-based probabilities with those decision outcomes. And so this is kind of a very preliminary kind of looking at evidence, hypothesis, prediction, decision, and action for the Bayesian network for decision making. And so step 5, we're looking at HCAI or human-centered AI. And so in the AADF framework, it's using to separate data input from AI processing and creating a kind of a continual cycle of human AI interaction. So that's ensuring that the decision remains transparent and accountable, and is aligned with some of those ethical considerations. And so in here, you're seeing that data input coming into that AI processing, having a human decision maker, some human input, and then going back into that processing. And then that loop can happen as many times as needed. And then as continual data comes in, that process will continue to go. So that kind of focuses on the human interaction rather than just data input, AI processing, and then outputting a result. And so some of the conclusions in future research we're looking at is that the AADF kind of demonstrates how combining emotional and analytical models can kind of improve decision-making transparency and trust and explainability. And so future research we're looking at is expanding the framework to domains like healthcare, military strategy, environmental decision-making, refining those DAG models for greater precision, and then scaling the framework to support diverse user groups and global applications. And so I would like to thank the Department of Defense and the National Science Foundation for their support, and also extend my gratitude to Dr. Liu and Dr. Rawat for their guidance and mentorship through the research process. Their contributions have been pivotal in the success of this research. Thank you all for joining.